All right, everybody. So we talked about last class finding critical points and then using the critical points and the endpoints in order to find out where my absolute mins, absolute maxes, local mins, and local maxes were. Today we're going to be doing exactly that. We're going to be looking at this problem here.
How are we not going about?
And we're going to find all the extreme values for this. Now, a lot of the times when you're doing these and I allow you to use a calculator, or you are allowed to use a calculator, you should first of all graph it. So, you don't really have to graph this one though. So you don't. You can if you want to, but you don't have to because the graph is provided for you down here. Do you all see the graph?
I do see it.
I do not. I'm missing.
Okay, I'm like, wait, did maybe you all not get the right print? Something mess up again?
Thank you.
nice.
I got it. I got it.
Smiley face without the eyes.
It's like it's right
It's a little
there.
creepy, right? So, the first thing you should do with these problems is solve them graphically. So go ahead and solve graphically. First. So, let's go ahead and look at this. What information do we know here? Here we have a possible max. Here we have a possible max as well. And here we have an absolute minimum for sure. What does it look like? About 0.5 at x equals 0. Sweet. So we have our answers. We're finished. Unfortunately, we're not. What we have to do now is we have to go ahead and analytically take this apart. If it's if you see graphically, that means you can use your graphic calculator, use everything. If you see analytically, that's when the calculus comes in. We have to analyze this equation and break it down. So, the first thing I'm going to state is that the domain is going to be from, I'm telling you right now, -3 to +3. Okay? So, you will be given the domain usually, not always, but usually. And then if you are not given the domain, then you have to treat it like an open function, not a closed interval function. So here we do not have that. So the first step should always be your derivative. So go ahead and take the derivative. Ooh, let's see how we do here. Everybody, go ahead and try it out. Not quotient rule. There's no function on top.
No, you're so right.
You don't have to use the quotient rule. You have to use the chain rule.
Oh,
Wait.
my favorite.
Oh, do we get a test?
Yes, you hopefully we'll get them back at the end of today. It just depends on. I just need to grade Ben's one. So if I can grade Ben's before class ends today, I can give them all back. But actually, no, I should be able to give them back anyway, and Ben can just wait. Sorry, Ben.
Wait, do you want to double check it? Oh, that's what you do. Okay, my bad. Why did you just cube it?
Because he felt like it.
Because I felt like it.
Why did we do any of that?
Great question.
Can't deal with it.
It's because you want phones, right? You want fancy electronics.
Yeah.
Then we gotta do derivatives. If we don't, we can't have that.
I don't.
Oh, I thought I heard someone just say like, "Why do we even do this?"
No, why?
Oh, I said, why are you
Yeah, you
using-
can just use the calculator.
No, he's saying like, why are you doing all that?
Why am I doing the derivative?
Why did you like
That's a
cube
great
it?
question.
Oh, so okay, so I'll write it out here. So this can be written as u to the -1/2, correct?
Which is that?
So then, whenever we use the power rule, you subtract 1 from here, you would get u to the negative, what's -1 minus 1? So what happens when I subtract 1 here? you get negative 3/2.
Okay.
So therefore it becomes 1 over the square root of u cubed.
Oh.
So then therefore this right here times up here negative 2x is going to become a x over the square root of 9 minus x squared quantity cubed. So we have our derivative. Sweet.
Awesome sauce.
Okay. Do we have any questions on how I did the derivative?
Sorry, how does the thing work when you do that? You take the 3 and you bring it down.
So no, you take this negative 1/2, you bring it down to the front, and then you subtract 1. So here,
No, I understand the power rule. I thought about like when you simplify it.
this, oh this here,
No, like when
The
you,
negative 3 cubed.
like you get root that cube.
Because you get negative 3/2.
Yeah.
yeah.
Good.
Sorry, Caleb, question?
Like, how do you bring u to the negative 3 halves? Take that.
Oh, well it just becomes 1 over, so this is times negative 1/2
Yeah, I got that.
times du. So this becomes u to the 3 over 2 because negative means you bring it to the
Okay.
bottom. And then this becomes 1 over the square root of u cubed because 2 in the denominator means a square, 3 in the numerator means an exponent. So we have our derivative here. Then we're going to go ahead and do the critical point. We're going to check all our critical points. Remember, critical points are going to be where we have zeros and where the graph does not exist. So let's first check for zeros. Set the derivative equal to 0. Oh, sorry, everybody. This should be a cube. My apologies. So, what can I do with the bottom? I can immediately just say, is this going to give me any zeros? Down here? Is this going to help at all? No. So what can I multiply both sides by? 9 minus x squared, square root, with a cube there. And if I multiply both sides by this, what's going to happen over here? This is going to
X equals
cancel. This becomes x is equal to 0. So therefore, at 0, we have a value. So check. We know we have 0. Then, what do we have to do with this? We have to check where it does not exist. So, I'm going to go ahead and change colors and say DNE. Therefore, now what am I going to do? When I want to check it does not exist, Emma, when I want to check that it does not exist, what do I need to set equal to 0?
the thingy.
Emma?
The x inside the
We have to set this, the denominator, equal to 0. Because what do we not want the denominator ever to be? 0. So therefore we have to set equal to 0 to check. So we get the root of 9 minus x squared quantity cubed with the square root on the outside is equal to 0. Does any of this fancy stuff on the outside matter really? No, because we can just square it, cube root it, and what happens? We're left with?
9 minus x squared.
So therefore x squared equals 3. And x is equal to, sorry, x squared equals 9. X equals plus or minus 3.
So you're just able to, how are you able to get rid of the square root of the cube root?
Square and cube 0.
I don't get it yet.
you square 0.
Oh, basically just get rid of it.
Wait, that makes so much sense.
And now, notice, usually we use the domain, but do we need to use the domain here? No, why not? Because what do we know about the domain? If we do the domain, does the derivative exist or no? No, it does not. So therefore, we're good. So let's go ahead. Now,
Why does negative
we have endpoints. I'm just going to put it over here. Endpoints do not need because of this. Okay, so because what are my endpoints? M1, what values did we just get here?
Positive negative 3.
Yep, so therefore what we do know is that it just does not exist. Because what happens if we input positive or negative 3 into this equation?
It gets undefined.
It becomes 0. It becomes undefined. So therefore, we're pretty much done. Because is there anything above this point here?
Are we saying that there's no endpoints because there's...
Because the endpoint does not exist. So here, we thought we had endpoints at negative 3, 3, but do we really have any endpoints?
So shouldn't it be
No.
closed?
So therefore, it's going to be, these should be open, actually.
Or no, sorry, I meant the domain.
The domain should be open then.
The graph just...
However, we just checked the domain real fast. That's what. So this was the case where I gave you the domain. Most of the time, that will tell you exactly what to look for, especially on the
domain
homework.
you're wrong.
But the graph...
It doesn't exist in 3.
Hmm?
It doesn't exist in 3. That's including.
I know that's why. So the whole point is that we use the graph that we just graphed to see where the important points were, and then we use that information there. Okay. All right. So now we have to figure out what is our minimum point. We want to find out in the end. At the end of the day, we want to find out what is the absolute minimum. Because is there any other information? Is there a local max? No. Is there a local min? No. Is there an absolute max? No. So we only have an absolute minimum. So I'm going to go ahead and do the function at 0 equals 1 divided by the square root of 9 minus 0 squared equals 1/3. There is an absolute minimum at 0, 1/3. All right, now let's go ahead and move on to another problem in a moment. Yes, Parker?
How do you know it's 0 then? Like, how do we know that 0 is going to be?
Oh, because of this here. What was our critical point?
Oh, 0.
And why didn't we input positive and negative 3? Because if we did input plus or minus 3, what would happen here? They would become 0, and therefore, yeah, we're done. Okay. So we're going to go ahead and do the finding extreme values exploration now. So for the first part, go ahead and follow the instructions. Determine graphically the extreme values of f and where they occur. So determine graphically the extreme values of f and where they occur. No. Wait, x squared plus 1.
So
Actually, just change it around, it looks like. So everybody, go ahead and change your window. And you want to change your Y max quite a bit. Your X max, X min max, you can change it to whatever window they give you. So there, they tell you from -2 to 2. So change your graph so you can only see from -2 to 2. And change your Y max so you can see it a little bit better. Yes, Owen?
Yeah. On the first one, why is it in square brackets?
Because that's what we just said it was for a while. So for this one, we just said they didn't give us a domain.
Oh.
So we just were given this graph. So we were like, okay, what are the critical points? Well, these could be critical points if they existed, correct? However, did they exist? Nope. So therefore,
there's an absolute value, not that.
Caleb's always good.
Yeah.
For sure.
It was a goofy ball, I might say.
So, if we look at the graph looks something like this. Correct? We have this here, and this here. No, that's about right, right? Is that good? Yes? Sweet. Okay, so what are the critical points for this graph? Can anybody tell me what the critical points are based on what you see here?
There's an absolute min of 0.
So it looks like we have a critical point. So remember, we're going to use the term critical point for all of these. What are all of our critical points?
0, 1, and
0, 1, and then -1. And then what else do we have? We always have to consider our endpoints, which are at -2 and +2.
Is that just in relation to the domain? That's just.
So that's just where they end, where the graph stops.
Yeah.
Because that's the domain, yeah, that is the domain of the function. So now, we have the critical points here, 0, 1, -1. What I'm going to do is I'm going to go ahead and evaluate all of them. We have f of 0 is equal to, what happens when we input 0? We are going to get,
Undefined 0.
nope, we should get 0. Here we go. Then we have the function at 1. The function at 1 is going to equal, input the 1 value in there, you should get 1/2. Then we're going to input f of -1, and we are going to get, yep, 1/2.
Good job.
We're going to input -2, and we get, what is that, 1/5? No, 2/5. And then f of 2 is going to equal also 2/5.
Where did you get like the -2 and 2? It's like
Because you always have to check the endpoints. You always check the endpoints. So if you look up here, where's my graph going from? From -2 to 2. And if you see this, does it include the 2's?
are you always given them?
Yes, you will always be given them. If you're not given them, a lot of the times it's because the graph is like this one. We told you, we looked at this and said, it looks like the domain is about -3 to 3, right? When we graphed it. However, in reality, it is from about 3. So this one doesn't actually have a domain of -3 to 3. It has parentheses -3 to 3.
Okay.
But we just guesstimated at that. So here we have all our points. So what we can say is that we have a absolute min here. Then we have our absolute maximum value. This is a little bit harder, right? I'm looking at this. I'm trying to consider it. Okay. Let's go ahead and just to make sure, let's move on to step number 2 now before we move any further with identifying which those points are. So let's go ahead and do number 2. What you're going to do is you're going to just click Math 8. Make sure to fill in all the information correctly. Savannah, good enough? Yes, your calculator is interesting for sure. Okay. And you're supposed to put that in your
That's what I
y equals.
That's what I meant to do.
There you go. You're supposed to graph them together.
Yeah.
Why is 2x not 2/3? Like I know we have the absolute value.
Oh, because it's x squared in the bottom still. So -2 squared is 4.
Wait, we're multiplying the function by its derivative. Yeah, okay, cool.
So looking at the derivative, what do you see?
It's literally like.
So
That's fine.
our derivative looks a little funky. If we look at the derivative, it looks like, I believe it, let me see actually here. Let me see that. It's going to look like
Just looks goofy.
this down here, and then this over here.
So fancy.
Okay. So we might not be able to take the derivative, because do you really want to try with this absolute value? Do you know how to do the derivative of an absolute value right now? No, it's actually not that bad. I'll show you how in a moment, but it's just, it does get a little bit difficult. So here, do we know now what our absolute min and absolute max are? Because we knew what our absolute min was before. Our absolute min was at 0, right? However, where does it look like the derivative is hitting 0? Where do we have that slope of 0? It's at 1 and -1. Therefore, these are both going to be our absolute max. They share the value. Our absolute max is at 1 and -1 for a total of 1/2. That's the highest this graph goes.
How does the derivative help though?
The derivative tells us, because we knew the critical points, we just guesstimated at 1 and -1, right?
Yeah.
We didn't really know. We just thought that looks like about where it's the highest. But with the derivative, what do we know at 1 and -1 at those exact points? What is it equal to? The derivative equals 0. Therefore, what's the slope? The slope is 0. Therefore, we have a maximum or a minimum. So now we have to do, okay, shoot, we have to find the formula. This is going to be rough, right? It's actually not that bad. Yes, Jillian?
How do you know when they're closed or open?
How do you know when they're closed or open? This one is closed because equal to.
Okay.
Okay? So the final thing we'll talk about with this graph before we move on to number 3, actually, there was one more thing, is what happens at 0 on this graph? The derivative, does it exist?
Nope.
No, the derivative does not exist, which we knew because whenever we have an absolute value, what does this look like? This looks like a cusp. Therefore, the derivative will not exist. Okay? We have that, that's what that means. So, in order to do the absolute value of f of x, so if I want to take the derivative of the absolute value of f of x like this, then what I need to do is I need to separate into negative f of x, where x is less than 0, and positive f of x, where x is...
the square root side.
Oh, sorry. This is like the, you know, the bracket thing?
Oh.
So this is going to become, whenever you're doing absolute value, it's actually pretty simple to take the derivative. You just can't take the derivative at the point, but instead what you do is you just have to do the positive version and the negative version. So the negative version of this formula is just going to be negative x over x squared plus 1. And the positive version is just x over x squared plus 1. So now we just have to take the derivative of both. So take f prime over here. Ooh, make sure you put f prime over here. So then we take the derivative of both of them. However, do we have to take the derivative of both? No, because what's the difference between the two? Negative. So all we have to do is do the derivative of this. And therefore, ooh, what do we have to do now? Is this a function?
Low d.
That's a function. Low d high minus high d low all over the square of what's below. Perfect. I feel like I'm on a TV show. You know those children's TV shows? It's like where you start saying something, they always repeat it. It's great. Okay, so we take the derivative. F prime of x is going to equal low d high. So negative, because what's the derivative of negative x? Negative 1 times x squared plus 1 low d high minus high, which is going to be negative x d low times 2x all over the square of what's below. So that is going to equal negative x squared minus 1 plus 2x squared all over x squared plus 1.
Squared.
Yeah, squared.
Oh, sorry, squared. Then we're just left with here, positive x squared minus 1 over x squared plus 1 quantity squared. And the other version
Wait,
is
so you just got
negative x squared plus 1 over x squared plus 1 quantity squared. This is for x is greater than or equal to 0. This is for x is less than 0.
How did you get rid of the negative 2x and the positive 2x?
Oh, what's 2x times x? 2x squared.
How did you get rid of it in your final answer?
Well, what's negative x squared plus 2x squared?
Oh my goodness.
I think it's swapped. I think x squared minus 1 is x is less than 0.
Which one?
I think like x squared minus 1. Do you see that derivative?
Mm-hmm.
That one is the one that's for x is less than 2.
Wait, no, because this is supposed to be no. This is the positive version, right? Because it's just the positive one.
Yeah, but we took the derivative of the negative one first.
No, we didn't.
Yeah, you did.
No, I didn't. Because we just did the. Oh, yes, we did. Yes.
You're so confident.
Yeah, no, you're right. Sorry. 1 second. Lucy, can you do me a favor? Can you run to the office and grab Miss Anderson real fast? Just tell her if she can come to Mr. Holmes class real quick. Or Miss Colorado is fine either way. So, sorry y'all, that is correct. So therefore, that is the derivative there, that is the derivative there, and we are all finished with this. Okay?
Would the things be swapped though?
Yes, no wait, yes, they would be fine. We'll swap them. I was just gonna try to see if I could just trick you. All right.
It's like solar sun.
So your homework for tonight is going to be 11 through 20. These are a little bit more conceptual. I'm gonna go ahead and let you get started. I just have to run to the bathroom real fast. Hopefully it's Sarah.
After he releases them. Yeah, I gotta watch the election.
Maybe right afterwards. Yeah. I believe we will have a progress check tomorrow.
What?
Yeah, it will be a hard one. It'll just be. It'll either be one problem or a couple of the more conceptual ones, just to see if you've got.
Probably like 7, 8, or 9.
No, not like 7, 8, or 9. So y'all can continue working on those. All right, Miss Calderon, I'm gonna teach you calculus. She knows all that straight run, bins, maxes, all that.
Yeah.
This is no homework.
That apple. You were drinking with that apple. Oh yeah, that was disgusting.
I always feel like
Absolute value of 8
Let's just say he's full, it's all white.
absolute value of positive or negative. So then you just took both.
oh for the
I don't get this. Derivative equals 0. You just said that.
Normal that I
I tried doing it on my calculator. Let me see.
my hair was very Elmer's derivative. My butt cheese on the same place. Gingers can't do that.
What was the homework? This is the derivative.
Mine was good.
If I drew you, I have to get another
What is
color.
that?
That's a derivative.
Specifically red.
So it equals negative 7 instead of 0.
Wait.
hurts.
Closing your eye.
This is the actual
Honestly,
value.
it's not
Negative
that bad.
0.021.
That was just the homework. Oh my god. Leave my calculator. Okay, great.
How is that? That's terrible.
Great, great.
So you gotta increase.
This drawing is terrible. Look, it's all my work. Whoa, whoa. Where did I get two? It's all my work from
You just now found it?
Yes, I learned to
That's insane.
It's all my stuff from
When did you lose it?
The heck? Flip.
like right in school.
X equals 1.
And then I have
2.5. Yeah, that's exactly right. I don't know. And then look, move one to the right. Like a 0 at 0.06382.
Grant, show them mine.
Oh, wait. I guess you're not gonna get that.
Okay, no, do it.
I could throw it.
What?
This is so bad.
Let me see.
Minus 2x.
We're just,
Oh no, I'm fine.
what? 11 through, I don't know the rest of it. What was it you just said?
Cody, are you ready to do number 7 on your own?
Oh, yes, I am. Honestly, it's pretty good.
This is so bad. I told you I can't do all, bro.
It's really hard.
Alright, everybody.
This is how I see you
So
in my head.
let's go ahead and look at number 10 real quick. Do we want to see one of these? Yes, no, maybe so. So, the first thing we're going to do is we're going to look at this. We're going to think, okay, well, do we have any endpoints on this equation? Is this an open or closed interval? It's open. There are no stopping points. There isn't even anything that has inequalities that are not equal. Because such as in here, if you look here, like we have an inequality here. So, for number 10, what we are going to do is first, we're just going to go ahead and take the derivative. Y prime is going to equal 6x minus 18. Therefore, 0 is going to equal 6x minus 18. 6x equals 18. X is going to be equal to 3. So therefore, we have an important point at 3, at x equals 3. If I input the 3 into there, I get 3 times 3 squared. So f of 3 is going to equal 3 times 3 squared minus 18 times 3 plus 35. That is going to be 27 minus, what is that, 54 plus 35. 27 minus 54 is that negative 27 plus 35 is positive 8. So is equal to, yep, positive 8. Yeah, so therefore 3 comma 8 is our point here. Is this going to be an absolute maximum, an absolute minimum, a local max, a local min? What is it? Our answer should be easy for the first two. Is there any absolute maximum at all? There is no absolute maximum. There is no absolute maximum or absolute minimum. Now, is there a local minimum? Sorry. Whoops. Nope, I was wrong on that statement. Sorry. This is a quadratic. So, if you think about a quadratic, when you draw it, what does it look like? Like so. So therefore, do we have an absolute minimum?
Yeah.
Yes, we do. Sorry, my brain was frozen for a second. So therefore, we have an absolute minimum. Are there any local minimums? No, there are not. We have no interval. We have no closed interval, no other point. So the local minimum is x equals is at 8 at x equals 3. Okay. again, the whole thing with this is just taking the derivative, checking zeros, checking does not exist, and then going on to, and then checking the endpoints. Then from there you just have to think, what does the graph look like? Where do these points end up? And right now we don't have a best way to tell the min and max. You are allowed to use your calculator the whole time right now. When we get to the point where we learn how to do certain tests, then you won't. Yes, Caleb.
Well, what if you didn't know what the graph looked like? How would
Then you
know?
should brush yourself up on the graph.
Well, like if the graph is more.
Then you just look at the big. You look at what number's the biggest, what number's the smallest.
So there's only one.
Here, there's only one. So that would be you have to know quadratic.
Well, no, I know a quadratic. Like, okay,